Hello everyone and welcome to Techability webinar on EquatIO, which is about accessible maths. My name's Neil Beck. I'm the Assistant Technologist for NatSpec Techability, and you can contact us on at tech_ability1. So if you've got any questions of anything today or anything that you'd like to see a webinar in future, then just let us know. And we're joined today by Patrick McGrath, Head of Education Strategy from Texthelp. Hi, Paddy, and thanks for joining us today.
Thank you for the invite. Much appreciated.
Great. And yeah, so please take it away and we'll ask questions as we go along.
Perfect. Thank you. Let me just share my screen here and we'll get things moving along. Unfortunately, Neil's put a time limit on me today, guys, so I'm going to apologize in advance if I overrun. I will endeavor not to. Problem with me and EquatIO and accessible maths is there's nothing more exciting in my world than doing a webinar on accessible maths. Genuinely, I do get somewhat carried away, so we'll endeavor to make it on point and we'll make sure that there's plenty of takeaways. What I have done at the end, I'll put an access link up as well, just for some follow-up info, not about the product at all. You'll be able to access that online at any time afterwards, but just in terms of how you use tools like this to build accessible strategies for maths. So we'll put that up at the end and hopefully Neil can remind you that on the follow-up to today. So as Neil said, I'm Patrick McGrath. I am Head of Education Strategy at Texthelp. It's a very fancy title, but really all it means is I get to talk a lot about teaching and learning and don't have to sell things, which is definitely a positive from my perspective. If you want to reach me after today, my details are on screen and Twitter handle there as well. But really the focus of today is not about me or about my contact details. It is about making maths accessible. So we're going to look at one tool from Texthelp, which is a tool called EquatIO. And we'll see how this tool can be used to make maths accessible across a range of different media. I'm going to look at it from two aspects. One of which from a staff aspect, and the second of which is, of course, from the student aspect. So we'll look at how we might create accessible content or perhaps patch content that isn't accessible and we need to make it accessible. And we'll also look at how we can use the exact same tools to help students access and engage with maths in a little bit more of an accessible way. So I'm going to state the obvious on the next slide as I go through. You've all been through it if you're teaching or lecturing in maths or any science subjects with any maths content. Maths on digital devices is a pain. Equation editors are challenging, to say the least. There are alternatives and plugins, of course, that we all know are available that make that a little bit easier. So perhaps for us as educators, we've found ways around this. We've found ways to create or to borrow maths from other sources, but that doesn't mean that we're going to be able to keep it accessible. So imagine taking those tools and putting them in the hands of your students. You've all been there, you've done that, and you know how difficult it is for students of any level of ability to experience maths in a digital environment. We've all seen that, of course, over the last year and a half in particular, with that massive move. But it's not just about that digital maths is painful and it's a challenge to create and it can be slow and it can be clunky. The main thing is for me, and the purpose, of course, of this webinar is that very oftentimes, unfortunately, maths is like the lost cousin. It's that part of the curriculum that actually doesn't get the same level of tools and attention in and around accessibility that it deserves, given its equal footing on the curriculum and how many students study maths. So the inaccessible nature of maths in a lot of ways is a particular challenge. So what we want to achieve today is go, well, how can we help fix that or make that better, both from the digital maths is painful bit and how do we make it more accessible? There are, and many of you will know this already, and I don't want to at all to be preaching to the converted here, but of course there are layers of challenges within maths. One of the big ones for me is that lack of standardization of how maths is created. So if we create an attempt to create accessible maths in whatever platform we choose, if we go down a LaTeX route or we go to something a little more visual like MathType or something like EquatIO, we're going to see Part of the challenge there is that that doesn't offer consistency for screen readers. So if you have a student who needs to be able to listen to maths read aloud, whether they have a visual impairment, whether they have challenges with dyslexia, and that screen read aloud piece is important there from an accessibility perspective. Many screen readers will not be able to interpret the maths that is presented directly on screen. So that standardization and that lack of ability to be supported by multiple screen readers is a real challenge. But of course, there have been strides there with things like MathML within Word, LaTeX, many of you may well have been using for a number of years, but that requires coding knowledge in and of itself in order to create that. Once you become proficient, it's fabulous. But to get a student proficient in LaTeX is way above and beyond many of the students that would necessarily be working with. Braille could be a challenge, and simple things like size of maths content. A typical maths textbook, as you know, if that's say a PDF version, the maths is very dense. It's not accessible many times that you look at a maths piece in a textbook. So that presents challenges all of itself. And then if we take formats that we would commonly work with, things like PDF. So simple things like past papers that are published online, not accessible by nature, a lot of them. And certainly when it comes to the maths content, if we have, say, illustrated handwritten maths as model answers within there, not accessible either. So there are all these layers of challenges within there. And of course, there are other challenges with maths when it comes to pupils with other individual needs. So if you take, say, a dyslexic student, and dyslexic student who may well have challenges in and around the abstract nature of maths and need something of relevance. They not only need access to tools that can support things like read aloud and traditional ways of inputting maths and listening to maths, but they also need access potentially to imagery, to manipulatives, to visual references that can actually tie some relevancy and take the abstract nature of that maths piece away. So they're basically, all I want to sum up in this slide is there's loads and loads of challenges here with maths. And so what we've done, so we've created this tool called EquatIO, and the vast majority of this time, for 20-25 minutes, we're just going to go through the tool itself and show you in action, because that's the most important thing we can do today. EquatIO is available on multiple platforms. So what I'm going to show you, I'm going to be doing it on a Google document, but the same applies if you're working with Word Online or a Word document on desktop, or if you want to use it with your own text editor as well, if you're using LaTeX, if you're using it on a web page, because it supports accessible maths across all of those platforms. Plus, it will pull accessible maths from images. So if you've got a photograph, a picture online of some maths content, maybe of an interactive whiteboard or a whiteboard or blackboard, we can make that accessible. Web pages, make it accessible. Videos, I'll show you. So something as simple as a Khan Academy video or an instructional video, we can actually apply read aloud maths to that. All the student has to do is pause it, and they can play back the maths and listen to that read aloud. They can also extract it and edit it and manipulate it. PDFs, very important because of the nature of things like past papers and textbooks and resources that we all reuse. So accessible PDFs, also accessible maths on paper. We won't have time today to show you that, but I'll explain it very quickly. And then on collaborative tools like Jamboard. So the short version of all of this is, we need to make maths accessible, but we need to make it accessible by everyone, staff and students everywhere. And that's what we have attempted to do with this EquatIO tool. As I mentioned, I'm using the Google extension. You can go away after today and you can download the Google extension the Chrome extension from the Chrome extension store. You can have that for free. Because you're an educator, you have that for free for life anyway. So it is free for teachers. You can access that straight away. So you just download it, install it directly into your Chrome browser, and you are literally good to go with everything that I'm going to show you today. What happens after you do that, and will not take any real time on this slide, is you'll effectively get access to these additional buttons. Okay, so these additional buttons, these 8 buttons that you're going to see and we're going to explore through, will give us the ability to enter maths by typing, by handwriting, by dictation, by taking a photograph of handwritten maths. Will give us the ability to graph easily with Desmos. So we've got accessible graphs. And one of the most important things there you'll see is a thing called Screenshot Reader. And that's going to give us the ability to listen to maths read aloud as well. All of these tools also work not only with the platforms that I've talked about, but in things like your LMS. So if you're using Blackboard, or if you're using Canvas, or you're using Google Classroom, wherever maths is, these same tools will support it in that exact place. So as I'm about to go through the toolbar that we have, those 8 features that we talked about, I want to draw your attention to 2 things specifically that are really useful to know. So in terms of takeaways, the first tool to really take away and think about after today, and for me, it was that tool that never got much love and attention, but that is called Screenshot Reader. And that's going to enable us to do so many things around accessibility. So we'll focus quite heavily on Screenshot Reader. This will enable us to have content read aloud, to extract it from other sources, to repurpose inaccessible maths and make it accessible. So there's lots of things we can do. And the second tool we're thinking about today in terms of a takeaway is how we can use the same tool, Screenshot Reader, but use it on PDFs to repurpose content, to make it more readable, to change the font size, to repurpose the maths content. So those are the 2 key takeaways as we go through. So I just want to stop talking right now through a slide deck. Don't want to bore you to death on that. What I really want to do is get stuck right into the platform itself. So as I said earlier, I'm going to look at a Google Doc. The toolbar itself appears just the same as if you're in a Google Doc or in a Microsoft Word document. So what I'm showing you is the same everywhere you go. So it's consistency for students. So I've opened this toolbar already just by hitting the extension button. And you'll see now that I have access to my EquatIO Maths toolbar at the bottom. We put it at the bottom because a lot of your screen reader tools are very own read and write. If you're using things like Claro, anything at all is likely to be floating near the top of your screen. So we'll dock EquatIO right the way down the bottom here. So this gives us those tools that we saw, the ability to input maths. Before we start with that though, because I'm going to refer to these things as I just go through, EquatIO has a number of options that are worth knowing about at the start. So before we look at it, I just want to show you a couple of things. So simple things, just so as you're aware, when we're creating maths, we can set the font size really easily here. Why that's important is we can take small content maths at a small font size, and we can very quickly change the font size and keep it accessible as we go. So for a student, say with visual impairments, we could simply change the font size on every piece of maths in a document from wherever source that maths comes from. I'll show you how we do that. Also, again, for pupils who have perhaps grown up with needing to have a screen reader to play back maths content, they may well need it read in a specific way. So they may well be accessing that on ClearSpeak or on MathSpeak. When we read back natively, we will read it back in natural language. So in other words, exactly how you or I would say the maths if we were reading it back. But bear in mind, for some students, particularly students with visual impairment, they may be used to ClearSpeak or MathSpeak. So we can set that. I'm going to leave it at automatic at this point in time. Other things that are there, in terms of limiting the toolbar, if we just want to give our students access to just a couple of key features, just to keep them focused on what can help them the most, we can switch those off directly in this area here as well. So there are lots of things here that we can do. And the last thing that I'm going to show you, and I'll just refer back to these as we go through the very quick demo, is in this area, we've got a thing called Chrome options and we've got autoplay. And what you're going to see us do here is when we highlight a piece of maths in a document or on a web page, it will automatically play it out loud if we've got that toggled on. Or we can have it so as we have to press a button or tab through to play that out loud. So there's many ways we can adjust the options here to help our individual students. So what I'll do is I'll jump straight into this document and I'll show you EquatIO in action. So I'm going to pop into the bottom of the toolbar and I'm going to pop into the first way to enter maths into EquatIO. And I'm going to use what we call equation editor. But don't panic, this is not equation editor like anything else you've ever seen. There are no big keypads of buttons. We don't have to search for a symbol. Why? Because this uses predictive text. If you've used accessibility tools, perhaps from ourselves, say our own read and write, when we're building natural language sentence construction, we'll prompt the student to help them build words. we'll use the same approach here when it comes to maths. Now I've set the font size here at extra large just to keep it so as you can see this on screen. So this is the default that I have picked for this. So if I want to type something super simple and I want to type a fraction, 1, and over could be the / key. So there's 3. I can go to one side and I can start to type the word plus because that's how I say it. And you'll see here that the predictive engine decides, you mean add or plus or whatever way we might say it. So there's plus, and perhaps I might actually say this is over. So I want to put a half in. So I could type that out as 1/2, ONEHALF, or I could type 1 and I need to start to speak it out loud so I know it's OVE over 2. Okay, and if I then go to the next part of the maths, equals, I could press the equal sign, or if I'm not sure about where that's placed on the keyboard, I can start to type EQ and it'll give me all of my options here. So hopefully you can see with just that EQ, I can get very simple mathematical operators here, or I can get something quite advanced. So I can go all the way through pure maths higher ed courses with the maths content that's here, starting from a very basic level. So I'll just go equals. So we'll not try and solve that, but once I've typed my maths, I can press insert maths just down the bottom right hand side, and that's going to insert it as an image directly into my document. Okay. Now, one of the things that's important about this is, and you may not see it just because of the resolution on the screen, if I were to hover over this, you'll see here that it's automatically applied alt text. And you may not be able to see the alt text here, but it actually says in natural English, 1/3 plus 1/2 equals. So that spoken text is available to me. Now, if you have a PDF, for example, and you need to create the alt tags, we can copy that really easily. So if we had a piece of maths and we had created the maths, instead of pressing insert maths, we can go here and we can say, I just want the spoken text in this window, which means that if I were to go here and press the paste button, the spoken text will be entered in. So that's me ready to pop that right into an alt tag if I was creating accessible content in, say, a PDF. So that's useful. That's just a simple fraction. I'm actually just going to change the size down here a little bit just so we can keep everything on screen. I'll keep it at large. This is pixel perfect maths, so this can be scaled and it means that it should stay pixel perfect. But let me go in and put something else. And so we'll give you another example. So I'll delete what's there. So this is just my editor window. And I want to do Pythagoras theorem. So I'm going to do A and I need squared. I don't need to go through the keyboard. I can just start to type SQ and there's my squared. And I'll do plus B squared. Okay. And now I'll do equals. So I just want to put the equal sign and C and SQ. And you can see all of the options for my prediction pop in. So again, insert maths. And I've now got that inserted directly into my document right here. And again, that's accessible, so it can be read out loud by any screen reader at all, whatever screen reader you're using, whether it's read and write or any other one, that can be read aloud. Now, if I go on down below here, I can also use prediction even further. So I'm doing Pythagorean theorem. I need to start and get the formula for Pythagorean theorem. So how can I do that? Well, I'll put PH in. No, I'm not finding Pythagorean theorem. I'll put PY. Now I can see the Pythagorean theorem is here. So I'm starting to link the language with the maths piece, and I can pop that directly in. So I'll put insert maths, and I'll pop that directly into my document right here. So I can use this prediction in a number of ways. I can also use other tools here. So as an example, and again, just due to time, we'll fly through this really quick, but I can use handwriting recognition. So I have this panel. I could have a touch screen or alternative input device, or in this case, just from a dexterity perspective, I'm going to show me just doing this with a mouse. Okay, so this is going to be scrolly and it's going to be at an odd angle. Okay, and as I start to write here, you'll see that on the right hand side, it'll start to translate into maths notation. And if I were just to press the insert maths button, that's going to pop that directly into the document as well. So now I've got maths that I've been able to handwrite, and that panel, I can change the size to be whole screen. I can also do multiple lines of maths. So if I prefer this to be the way to input maths, then I can do it right here in this particular panel. So it's nice and easy to operate. The other thing that we can do, so think about multiple means and other ways we can do this. we could use dictation. So many of your students may well be used to dictation in terms of, from a literacy perspective, to dictate words. This gives them the ability line by line to basically speak maths out built into the same toolbar. Now, sometimes this doesn't work very well over Zoom because of the way microphones are set up, but let's try it anyway. X plus Y equals 3. So kept it simple there just for speed. I'm going to insert that. And that maths is now inserted into my document. The only difference between handwritten maths and dictation, handwritten maths, I could do multiple lines if I'm working through an answer. Dictation, I need to do it one line at a time as I go. Insert it, next line, insert it. So that's the only limitation there. And I got a wide range of operators that can support that. Speaking of multiple lines, I can also use the same equation editor to do multiple lines here. So for example, I want to do volume of a sphere, okay? So I'm going to look that up really quickly. And to solve this, I'm going to have to start to type this out. So I'll do 4/3 and I'll do pi, and it's found my symbol, and I'll do my radius was 5 and my cube, so I can start to type. And now I've got multiple lines of maths. I can again insert the maths content directly in there, and it's going to pop into the document. While I'm on the insert button, we've seen that insert as an image. We've seen it insert as spoken text, that natural language, but you also have access to this in MathML, in LaTeX, in HTML, as a vector format, as a direct URL, or you can simply download the maths piece as an image file. So there's loads of ways, depending on the platform you're using, that you can insert maths in. I've just chosen this to default it because it's easier within the context of Google Docs to do it directly as an image. So I've inserted that. So that's directly in. So that's good. We now know how to create maths. What about playing it out loud? You'll know in terms of screen readers, what I've said previously, all of the alt text is directly there. So if I were to open up something like my read and write, okay, and why not? It'll read out the language. 1/3 + 1/2 =. But it's also going to read out the maths correctly because it has that alt tag, and that will apply to any screen reader at all. What happens if you don't have a screen reader is the screenshot reader piece that we have here. So what could this do for you? Okay, so we'll go down here and we'll say, right, we just want to read this piece out. So all we do is screenshot reader, click, and we're just going to drag our box over the maths right here. And if you remember back to the settings, I set it back not to default to play automatically. We could have set that so as soon as we draw the box, it plays back, just to allow me to speak over this. So I'm going to press the play button. 1/3 + 1/2 =. And you'll hear that read out loud. Okay, so I'm going to close that. And this applies in loads of different places, which I'll show you as we finish off today. If I go to my 2 lines of maths here, the same will apply. So screenshot reader, draw over the maths. And we'll press play. 2 lines, line 1, v equals 4/3 pi r cubed, line 2. You may not have heard that very clearly through Zoom, but it told me that there were 2 lines of maths. It told me the first line that it was reading out, and then it read through the maths in natural language, and then it moved on to line 2, and it'll go through that. So this can do any amount of lines of maths. So if we don't have a screen reader for our students, we can use this screenshot reader anywhere that we want. I'll show you in another couple of places before we finish off today. So speech is there with screenshot reader, and there's a whole lot more besides that. Screenshot reader, remember we said this is one of the really key things to look at as we go through accessibility. Screenshot reader will also let us repurpose maths and make it accessible. So this is an image, and what that is a screenshot. Many of us have come across it. It doesn't look much like maths. It's not a grade X and it's not a grade pi within there. So this is a screenshot I took from a past paper that a teacher had created. It's not accessible. It can't be read out loud. It can't be edited. We can use this same function, this screenshot reader, to make it accessible really easily. Click the screenshot reader, draw over the maths really quickly, and let go. And now you'll see the correct notation is there. Pi is correct, X is correct. All of the maths notation is there. If we were to press play. P equals 4x plus pi x over 5. Okay, so that's read it out perfectly. But you may not have saw before these 3 buttons. And these 3 buttons will allow me to edit this with EquatIO. Remember, this wasn't accessible maths. It wasn't created in EquatIO. But if I click the 3 buttons and go to edit with EquatIO, It pulls the previously inaccessible maths down to the bottom. It tidies it up and makes it into the correct notation. It makes it accessible. I haven't done anything but click those 3 buttons, and I now can press the insert maths button. Okay, and if I press the insert maths button, we've been able to take a piece of maths that wasn't accessible, wasn't readable, wasn't editable, and we've been able to, in 2 clicks, turn it into accessible maths that could be read back by a screen reader, that could be edited and changed around. So this gives me the ability to go into any resource and repurpose that to make it accessible. Now, I can do that from other places as well. So if I were to jump out of here and go right the way through to the past paper. So this is just a PDF. It's a fully inaccessible PDF. Nothing can be read back in this PDF and accessed. All I need to do on this is open EquatIO and open my screenshot reader just like we did before. And I'm going to circle around the question because I maybe want to reuse that question, or I want to make it accessible in another way. I can draw around it. You can see now I can play it back.
2 lines, line 1, f of x equals x squared plus.
And you'll see it's grabbed the English in there as well, not just the maths. I can press copy LaTeX. So I'm copying the maths, the raw maths. I can go back to my Google document or my Word document, go back to my toolbar. And all I need to do here, just going to get rid of the last piece of maths, is press the paste button. It pastes in the LaTeX. It now creates the maths. And if I press insert maths, guess what? That maths now is directly inserted into my document. Okay, so now I've got accessible maths. I can change the font size. It can be read out loud. It's fully editable, so I could change variables within that and make variations on that individual question. I've lots of things I can do here because I've been able to extract it from PDF. If I go back to the PDF, the model answer, not that neat, not that clear, and certainly not that readable. With all due respect to Corbett Miles and David's past papers, this is not very accessible. But if I now open again my EquatIO toolbar, screenshot reader as it was before, and now I'm going to just draw over the handwritten maths, what happens is that now is converted to digital maths, which is accessible instantly. It can be read aloud.
5 lines, line 1.
It's telling me there's 5 lines, line by line, it's going to read it out loud. But if I want to take that maths and I want to copy it and pop it back into my document, all I need to do in my LaTeX, delete the last part that was there, paste that in, and there is my accessible maths now here. I can do this in Word, I can do this in Google Forms, I can do this in Google Jamboard, I can do this in Excel, I can do it in PowerPoint, I can do it in Google Slides. Anywhere that I want to reuse maths and have it accessible, I can do that. And remember, this is all resizable, so it's just an image. So I can still have accessibility and resize that. And remember, I put that in as a large image size. Anytime I grab this maths, I can edit it too. So I could also just go here to my screenshot reader. Remember, we were focusing on this particular tool, and I could draw around this maths, which was accessible, and I could just go to edit with EquatIO. And now I can say, actually, I'm going to put a variation on that. I want that to be 6. I'm going to insert the maths. And now I can create variations on the one question really, really easily. So that's going to replace that maths directly on screen. So there we go. Now, almost there, guys, as we go through, but other things that I have here. So things that we won't have time to show you. EquatIO Mobile. Why is that useful? A pupil or a student who might want to prefer to handwrite maths on paper, how can that be made accessible and how can it be made digital? All they need to do, take out their mobile phone, hold the camera up to that QR code. It will allow them, without installing an app, to take a photograph of their handwritten maths. It'll automatically convert it to digital. It'll automatically add it into the document and it'll make it fully accessible. So we have the ability to take a photograph of maths, handwritten maths, and convert it accurately and with accuracy and make it digital and accessible. Other things that are here in terms of an accessibility piece, really easy one to start off with here, just a graph. So we've got Desmos built in. So I just previously populated this before, come on, just a simple sine graph. But of course what we have, because we've got Desmos built in, we've got Braille mode directly in within here. We've got reverse contrast mode, if that helps from a readability perspective. We've also got the ability to audio trace. So I can switch on my audio trace, and you won't hear this fully, but it'll cycle across my speakers from left to right. And if I simply press the H button, not a line of duty reference there, it has to be said, but we press the H button and we'll be able to hear that graph and move between the lines. So in terms of accessibility, we've got those pieces built into the graphing as well. And last part of accessibility is in terms of images. And I want you to think slightly differently about this one, which is if we take a student, we talked about them earlier, for example, a student with dyslexia who might struggle with the input of maths here. Prediction will probably help them. Read aloud might well help them as well. But if it's the abstract nature, imagery might help. So for something really simple, we've got the ability to jump into this math space, okay? So in math space, what we can do here is we can press the button on the toolbar, and now we've got the ability to jump into simple things like this. So if we wanted to express a fraction as an example, and I'm just using a basic format here, we can draw the fraction imagery here. We can change the number of segments that we might want to do. And we can take this right away from basic fundamental concepts of maths. We can take it through chemistry and physics equations, all the way through for our adult learners, and we can take it through to higher ed maths. So any level of maths has corresponding images and manipulatives that can help with basic concepts through to the most advanced things. And again, from an accessibility perspective and ease of use, all I need to do is press the insert button. It's just up the top right hand side of my screen. And that image that I have explored to illustrate that fraction concept, that 5/8, is now installed and popped into my document. It's resizable, it's accessible, it can be read out loud, all of those things are there. So EquatIO gives me all of these different ways to insert maths and consume maths. I'll show you two last things just before we start to wrap up here, and hopefully Neil will keep me right on time. I know Neil, I'm over a little bit already, so we'll endeavor to be finished in just a few minutes. The same things apply in terms of accessibility on a web page. So here's me in a fairly complex, dense web page, Wikipedia. But you'll see there that what's happened is EquatIO automatically has went and found all of the maths content on this page, and it's highlighted in blue. That means I can go through that in tab order. And in tab order with EquatIO, because all of the controls in EquatIO are tab order, they're all switch controllable as well. It means that I can tab through any of these and have the maths read aloud. Now I can go from the most simple, this one here, and have it read aloud just by pressing the camera button. And I have shortcut keys for this as well. I can hear it, so I can listen to it. I could also do what I did previously in that PDF. I could just capture it, so I could edit it directly in EquatIO and put it in a document or a slide deck. I could copy it as MathML if I wanted to reuse it in a Word document, or as LaTeX if I wanted to use it in a text editor. That's not overly useful in 8x-5, but when you get to this complex piece here, we can grab this, capture maths, we can have that read aloud, or we can capture it and we can reuse it anywhere that we want. So maths is discovered by EquatIO on any online pieces, and it can be read aloud, and it can be captured, and it can be made accessible. So whether we're in PDF, we're on web page, whether we're looking at images, whether we're looking in Google Jamboard, whether we're in an LMS or out of it, we have the ability to do all of these core things with maths and enter maths in with those tools. And the very last feature, which is always worth showing, I think, is this. Many students will rely on video, whether it's instructional pieces from yourself that you've put together, or it happens to be YouTube help. And this one is one of the early Haggerty Maths pieces from many years ago, but still a very relevant and very useful piece, GCSE syllabus. All I've done here is I've paused the piece that I might have been struggling with after this has been explained, and you'll see here that Colin has started to fire over some additional lines here to start to move that content and start to make it relevant. I don't want those read out loud, but what I can do is I can go up to EquatIO, my toolbar opens. Again, the toolbar opens the same everywhere it goes, so it's a consistent experience for your students. They know to rely on this screenshot reader. I can tick my screenshot reader. I can go all the way up to this maths piece that I have right here, because I want it read aloud. So I can do two things. Think about screenshot reader. I can have the maths piece grabbed so it makes sense this way. I can have it read aloud.
3 lines, line 1, the fraction with numerator open, parent 16 minus x, close, parent and denominator.
Okay, or I can grab it and I can reuse it. If I wanted to take that maths from our Haggerty video, I could jump right the way in. I could press copy LaTeX. I could go all the way back to my Google document. I could click anywhere I want to paste it, and I could go here and I could just press my paste shortcut on my keyboard. There's that maths from the video. It's accessible. It can be read out loud. It can be edited, and it can be used in any way that suits me. Now, EquatIO has so much more to it, and we've only been able to go through it from a pure accessibility perspective. There's lots and lots to offer with EquatIO, things that we haven't had time for. There's an accessible scientific calculator. There's the ability to jump in and have an accessible periodic table. There is an accessible molecular viewer here as well. So there's lots and lots of things here. And the most accessible thing to me right now is jumping into caffeine, and there we can get an accessible model of caffeine right there. So this will give us the capability to access maths wherever we go. So just to finish off here, think about how that might support individual pupil needs. Areas: dyslexia, underlying dyscalculia, dysgraphia, dyspraxia, the ability to focus on certain areas, the ability to link abstract concepts with fixed maths. There's so many ways that this can start to help. Because it's tab order, because it's switch control, because it'll work with other screen readers out there, we've got a tool now that can either be helpful for creation of maths, be helpful for fixing of maths that isn't accessible and repurposing it, or perhaps simply plugging the holes of partially inaccessible content like PDFs, where we need to generate things like our alt tags. So that'll give us the sort of the real heads up. But think about these last few things, and we'll put these in a document for you after today. The core things that we've went through: read aloud capability, that screenshot reader support, the ability to use LaTeX if that's something that you currently use, and to work with current LaTeX editors. If you've got a bunch of code and you just want to make it accessible, you can paste it right into EquatIO and that'll make it accessible. That web page read back, the ability to copy and make accessible just by drawing the screenshot reader over inaccessible images or maths content from any location. And most importantly for me, from your students' perspective, the ability to engage with maths in a way that suits them. Dictation, the ability to type and use that prediction, the ability to handwrite, or just that photograph tool if they prefer to handwrite on paper. So there's lots we can do to help you on this. There is a link here that I'm going to send you out hopefully after today in conjunction with Neil. And everything you could need to get you started with EquatIO. Remember, this is entirely free for teachers and educators. There's a wakelet. It has videos on each of the core areas. If you decide you want to use EquatIO in, say, Google Forms to make those more accessible for assessment for students, you can have all that accessibility in Google Forms or in Microsoft Teams or wherever you happen to be using it. For students, we've got an interactive tour so they can go around the toolbar and they can figure out what works best for them. That's all fully accessible. So that's all read out loud, and that'll give them a quick tour. If you want our guide to this, and Neil, I hope you don't mind me just throwing this up. If you want our guide to this, if you email me, edtech@texthelp.com, you don't need to write anything in the email. Just pop in the word maths in either the title or the body of the email. Nothing else is needed whatsoever. Email that through to me and we'll get you what we call our guidance workflow. And this is really, how do you use the accessible features of EquatIO to make things more accessible? What does good practice look like to take what I've shown you today and implement it across the curriculum for you and for your students? And that, Neil, I think takes us up to the end. You did say you'd give me an extra 10 minutes there, and I did take liberties there with that 10 minutes, pushing it right to the envelope. But I wanted to thank Neil, you and the team at NatSpec there for having me today, and for everybody who turned up. I'll pop my contact details on the screen there, but if there's questions, I'm more than happy to take them, Neil.
Great, thanks, Paddy. That was excellent, and there is a lot to cover, to be fair. First question, actually, I'd like to ask the people that have attended, do you feel comfortable going away and using this? Is there anything that you're missing that you'd like to ask Paddy? Is there anything else that you'd like to see more of? Any other questions you've got, let us know. My question, Paddy, is we've done a lot of demonstration on Google Docs.
Yeah.
If someone was using kind of Microsoft Teams and all that kind of system, what's the best step? What's the first step for them to access all of this?
So it's in terms of the interface, Neil, it's exactly the same. So the toolbar will look the same and all the functions that we went through are identical. The only difference, literally physically, you're looking at my browser window now, is that when you open your, say, your desktop copy of Microsoft Word, the toolbar will sit along the bottom of your taskbar and the bottom of your screen. It'll look and perform exactly the same as we've seen. So all you've got to do to download that is you can go and we can send the links out after today. You can download again that free from our website, texthelp.com. Just pick the Windows version, download it. There's also a version for Mac as well. I'm a Mac user, so I have the Mac version installed. But again, it looks the same and it just sits along the bottom of your actual screen rather than in my instance, it sits across the bottom of the browser window. So my recommendation is for everybody, if you're using Chrome, install both. Install the version for your desktop and install the Chrome version, because the Chrome version is so handy for the web. And if you're used to sitting in Microsoft Word, and actually, Neil, one thing on Word that's quite useful that I often forget to mention is your colleagues don't necessarily have to be using EquatIO to get the advantages of that accessible mouse, because if you create the accessible mouse in EquatIO, and when it's used in Word, it'll pop it into Word in MathML rather than that image that you've been seeing, which means that when your colleagues get a hold of this document and they need to edit it or they need to modify it, they can just open the standard equation editor in Microsoft Word and they don't need EquatIO to do that. So it'll automatically manage that for you as you go.
Brilliant. That's really good. I always like to lead people with one step where they can go and just start using this themselves. So great. Thank you so much for coming, and thanks for outlining all of this. Anyone who's attended, if there's any information you want more on this, then let us know. We're going to invite Texthelp back to do some more webinars on some of their other screen readers as well. If you have any kind of friends who are maths tutors in particular, or might be interested in this, then make sure to share the YouTube recording with them. We'll email that out to everyone and it'll be on our usual playlist. So I'm just going to share my final screen. And yeah, if there's any other, so today we thought this would be really interesting for you all, but if there's anything that you think you'd like a webinar on, then just let us know. You can email techability@natspec.org.uk. Or you can follow us on Twitter. Those are probably the best ways. And yeah, we'll leave it open for another few minutes. Let us know what you think. We'd love to hear back from you if this works for you, if you've used it with learners and they get on well with it. We always love to hear case studies because it means we can share with other people how it's worked. And yeah, thanks again, Paddy.
No problem. Thank you very much. Really appreciate the opportunity. Always love working with you guys. Help them where we can.
Great. And yeah, I thought the timing was good. We always say half an hour because we expect people to overrun.
You know, people run over you.
Yeah, it's better. At least that way we can relax and let it go that way. So as I said, we'll leave the chat open. But thank you, everyone, and take care, and we'll see you soon.
Thanks all. Much appreciate your time.